Okay, so derivative, nothing more than rate of change. As a matter of fact, we refer to it as average rate of change because I'm doing f of b minus f of a all over b minus a. So average rate of change, that's nothing more than my crazy slope formula, delta y over delta x. Change in y over change in x. And that's mostly due to the fact that I just have 2 points, a and f of a, and b and f of b. And so I'm just finding the slope between them. Now, derivative actually gives us instantaneous rate of change because by definition, it's the slope of a tangent, so there's only 1 point. So that's the difference in the two formulas that you're using. What happens when I have 1 point versus the difference in having 2 points? So one is instantaneous, the other is across an amount of time from A to B. So of course I bet you're wondering the question, when am I ever going to use this? Well, actually a lot. So derivatives can be applied in lots of ways, and I've listed some. You will definitely want to jot all of those down. We're going to spend a good deal of time on 2 of them in this chapter, one being velocity, the other being acceleration, and one that's tied to that is position, because the 3 of them are actually related to each other. So the first one, position, talks about where an object is relative to the origin as a function of time. And you might have heard this in your physics class. It's also known as displacement. So if you remember from physics class, or if this is the first time you've seen it, that position is represented by s of t, that's our notation, and will be all year. We'll always use s of t. And so I have this fancy formula, which you won't actually have to memorize, but it'll be, when it's given to you, you don't have to know what it stands for. So I have 1/2 g of g times t squared plus v. This is a little subscript of 0, which just tells me at the beginning of time, or at the beginning of whenever it is that I'm starting, times time, and then the initial position. So really when you see these zeros, they mean initial velocity and initial position. So in other words, I might be actually dropping something from the top of the Eiffel Tower, so the initial position might not always be 0. So, and here it tells you s sub 0 is the initial height, v sub 0 is the initial velocity, and then g is acceleration due to gravity, which depends on whether I'm measuring using metric system or English units. So, and I would anticipate you've probably seen that formula in some science class before. And so imagine, or just remember that position can be positive, negative, or 0, based off of where it is with respect to sea level. Or at least with respect to the origin if I'm graphing it. So the velocity function tells me the rate at which my object is moving, and it too can either be positive, or negative, or 0 if it's not moving at all. But if it's negative, it tells me it's moving down, and if it's positive, it tells me it's moving up, or this could be left, and it could also be moving to the right. This is actually a P. And so the sign really indicates direction. And my velocity function will always use v of t, and what it is the first derivative of position. And of course this represents instantaneous because I'm doing first derivative, not an average rate of change. Now, the average rate of change, average velocity, I'd have to use my slope formula, which would be s of b minus s of a over b minus a. And in other words, we could call that change in distance over change in time. Okay, gonna run out of video. See you on the next segment.